Good evening, viewers of Akshi.com, by Vetri from Pondicherry. So let me discuss now quantum numbers now. We have come across quantum theory, that is the particle theory, and this quantum theory taken into account of the uncertainty principle proposed an equation. That equation is called Schrödinger wave equation. That equation is called Schrödinger wave equation. What is that equation? Dou squared psi by dou x square plus dou squared psi by dou y square plus dou squared psi by dou z square plus 8 by squared m into e minus b psi divided by s square equal to 0. This is the famous Schrödinger wave equation proposed by quantum theory. What are the terms involved? X, Y is a 3 coordinate axis. E, total energy. V, potential energy. Psi, amplitude of the wave function, that is function. That is psi square, probability of finding an electron in space. What is orbital? Let me define now. So, an orbital is defined as a 3-dimensional region around central nucleus where the probability of finding electron is maximum. That is called orbital. So, kindly follow me. Suppose you consider an atom. The atom is having a central nucleus and the electron is moving around the central nucleus in various spaces. So, this space, we are calling it as an orbital. An orbital is defined as the 3-dimensional region, x, y, z axis. 3-dimensional region. 3-dimensional region around central nucleus where the probability of finding electron is maximum. That we will call it as orbital. So this orbital, we can take various types of orbital. What are they? S orbital, spherical in shape. P orbital, dumbbell, shape is dumbbell. D orbitals, double dumbbell. F orbital, complicated structure. So let me show you the orbitals picture. You can see. What you are seeing is S orbital given in 3 coordinate axes. X axis X, Y and Z axis, 3 coordinate axis. Here S orbital is shown. So this is the shape of S orbital, spherical. The next one. This is P orbitals. There are 3 P orbitals, Px, Py and Pz. So orbital orienting along the x-axis, Px, orbital orienting along the y-axis, Py, orbital orienting along the z-axis, Py. So there are 3 P orbitals. And coming for the D orbitals, and there are 5 D orbitals, dxy, dyz, dzx, d squared minus y squared, and dz squared. There are 5 D orbitals. Students, here I want to give one information. Kindly keep it in your mind. Because when we go for +2 level, when we are studying the coordination chemistry, the difference between, that is the 5 orbitals can be grouped into 2 types. So there we will be discussing. So that information I want to give here. The out of these 3, that is 5 D orbitals, the first one there among these 3, dxy, dyz and dzx are orienting between the axes. Whereas these d square minus y square and dz square, the d orbitals are orienting along the axis. That is the only difference. So here temporarily you just know this is the d orbitals are having double dumbbell shape. Okay, let me go for the next. So now let me come for quantum numbers. I have already pointed out, when we are solving the Schrödinger wave equation, and 3 values are, instead of value I can call it as 3 numbers. Instead of value I can call it as 3 numbers. And that 3 numbers are nothing but n number, n value, call it as principal quantum number. L value, call it, I will call it as azimuthal quantum number. M value, I will call it as magnetic quantum number. So these 3 values are numbers obtained from Schrödinger wave equation. That is the information, only thing we need now. Okay, next question you can ask. What about spin quantum number? I can give information, kindly have it in mind. Spin quantum number is obtained only from spectroscopy. That is the only thing I want to record. Principal quantum number usually represented by n. Kindly compare the n value proposed by Bohr. Bohr also given n. Level, energy level, n equal to 1, n equal to some more, then they are identical. Okay, now let me give some information. What is principal quantum? It gives information regarding the location and energy of electron. So we have discussed already, there is an atom, the nucleus at the center, electron is moving around the central nucleus in 3-dimensional space. And this space we are calling it as orbital. It may be s orbital, it may be p orbital, it may be d orbital, it may be f orbital. And so it gives, the principal quantum number gives information regarding the size of this orbital. This is the most important information. It gives information regarding size of the orbital. The number n representing the energy level is called principal quantum number. Okay, what is the energy level? N equal to 1 represents the energy level, it is the nearest to the nucleus. And n equal to 2, which is far away from the nucleus. So n equal to 1, that orbital is very close to the nucleus. 2, far away. 3, far away is going on. So the radius and the energy of different energy level in an atom is given by n value. I have already explained you. I have given already the equations. Okay, next one. The maximum number of electrons, this question can be answered competitively. Maximum number of electrons, each shell energy level is given by 2n square. It's a formula is given. 2n square, where n equal to level 1, level 2, level 3. So let me give you now. Suppose when n equal to 1, the shell, we'll call it as K shell. Again, we have discussed already under the Bohr, K shell. So 2n square means n equal to 1 means 1 square, 2 into 1 square, nothing but 2. So maximum number of electrons, the first level will be 2. That is the most important. When n equal to 2, we are calling it as L shell. So n2, substitute that, we will get 2 into 2 square, nothing but 8 electron. So maximum number of electrons that can accommodate at second level is 8 electron. The same way, n equal to, this is given wrongly, 3. n equal to 3, m shell. So 2n square, 2 into 3 square, that is 18 electrons. Same way here, n equal to 4, n shell, 2n square, 2 into 4 square, nothing but 32 electrons. In the fourth level, 32 electrons will be there. So this is the most important. So the first level, maximum electron 2, second level, maximum electron 8, third level, maximum electron 18, and the fourth level, maximum electron 32. Okay, let me go for the next. So next question, second, azimuthal quantum number, usually represented by L. So kindly for our comparison, you just compare with our Sommerfeld theory. Okay, azimuthal quantum number gives information regarding shape of the orbital. Principal quantum number gives information size, because if we know n, we can calculate size of the orbit and energy also. But in this case, azimuthal quantum number gives information regarding shape of the orbital. It is also known as, another name for it, orbital quantum number or angular quantum number, usually represented by L. That means each value of L corresponds to energy of a subshell. Kindly follow. So Bohr says main shell. Now second, automatically Sommerfeld subshell. So here azimuthal quantum number L indicates subshell. Okay, what is the relationship between the principal quantum number and azimuthal quantum number? For each value of n, the possible values of L values are 0 to n minus 1. This is the most important information. So if you want to calculate L values, if you know n, we can calculate L. What is the formula? That is n minus 1 values including 0. So the subshells are designated as S subshell, P subshell, D subshell and F subshell according to the values of 0, 1, 2 and 3. Thus, let me explain now. When L equal to 0, we'll call it as S subshell. S stands for sharp. When L equal to 1, it is called as P subshell. P stands for principal. L equal to 2, D subshell. D stands for diffuse. And L equal to 3, F subshell. F stands for fundamental. So, if you know L value, we can immediately calculate L value. And if you know L values, the corresponding subshell, we can identify. Yes, I have already pointed out subshell, spherical. P, subshell, dumbbell. D, double dumbbell. F, complicated. Okay, next. So, we can calculate number of subshells, that is L value in energy level, is equal to the principal quantum number. This is another important. That nothing but n, whatever n value, that is the number of subshell. That is n equal to 1, L equal to 0, the first level, only one level 0. That we'll call it as 1 means 1s. So L equal to 0, yes. N equal to 2, there are two subshells, 0 and 1, that is two subshell, 2s and 2p, second level. When n equal to 3 number, so there are total number of 3 subshells, that is 3s, 3p and 3d. The same way, n equal to 4, 4 subshell, L equal to 0, 1, 2 and 3, 4 subshells. So 4s, 4p, 4d and 4. This is the most important because we know that is L equal to n minus 1 values including 0. This is the most important information. Now, azimuthal quantum number L, again some more information. So we can also calculate the total number of electron each subshell is given below. So total number of electron each shell 2n square. The same way, total number of electron each subshell, again I am giving an equation that's nothing but 2 into 2L plus 1. 2 into 2L plus 1. L is the corresponding azimuthal quantum number. So here I have given the list. So this is L value, this is subshell, this is the max number of electron. So if it is 0, apply this 2 into 2L plus 1 formula. If L equal to 0, automatically you will get 2, max number of electron. S orbital, 2 electron. But L equal to 0, that we are calling it a P subshell. In P, the maximum number of electron will be 6 electron. So we know already Px, Py, P is that, so maximum 6. When L equal to 2, it is called as D subshell. The maximum number of electron will be 10. In the case of L equal to 3, it is called as F subshell. The maximum number of electron will be 14. So kindly have it in mind. So total number of electron in subshell can be calculated using this equation 2 into 2L plus 1. Okay, next. Third one, magnetic quantum number M, usually represented by M. So the magnetic quantum number gives information regarding orientation of orbitals. Orientation of orbital. So here I want to give. So just to take what is the orientation of orbital? I have shown you already P orbital. Px, Py and P is that in x-axis P orbital is oriented, I will call it Px. In y-axis P orbital is oriented, Py. The same way P is that. So magnetic quantum number gives information regarding the orientation of orbital, usually represented by M. What is M? So M can be given as 2L plus 1. So if you know L value, we can be able to calculate M. So where is including again minus L2 plus 1, that is minus, that is L2 plus 1 including 0, that will give the M value. So each M value corresponds to a specific orientation of orbital in space. This is the most important information regarding the magnetic quantum number. So let me give some more information. So this is the list I have given. So under the magnetic quantum number M value, we know the formula m equal to, that is 2l plus 1, that is the value. You can. So when n equal to 1, the corresponding L value is 0. What about m value? It is 2L, it is again only one value, it is 0. L equal to 0, 2 into 0, 0, plus 1, that nothing but 0, 1 value. The same way, when n equal to 2, m minus 1, so again L value is 0. If it is 0 means again 2 value will get now, that is 2, 0 means again m value is 0. For another is 1, n minus 1 again, L equal to 1 means we'll get now 3 values. 3 means minus 1, 0 plus 1, that is minus L, 2 plus L, including 0. So minus 1, 0 plus 1. The same way, if you take m equal to 3, there are 3 sublevels, 0, 1 and 2. There are 3 sublevels. For sublevel 0, only one magnetic quantum number 0. For subshell 1, again there are 3 sublevels based on the orientation. I can say 3 possibility, 3 orientation. So minus 1, 0 plus 1. That is Px, Py, P that is. When you come for third, that is again 2. L value equal to 3. When L equal to, sorry, L value equal to 2. When L equal to 2 means again the possibility is from minus 2 to plus 2. So there are 5 orientations. We have discussed already in the case of d orbitals, dxy, dyz, dzx, dx square minus y square and dz square. So this is the way we can. Let me go for next. The spin quantum number. This is the most important information I want to give. Spin quantum number, the fourth quantum number is obtained only from spectroscopy. That will be enough for you. So let me give it now. Spin quantum number gives information regarding the orientation of electron, usually represented by S. This is the most important. So I have already pointed out it is obtained from spectroscopy. Let me go for the next. So the spin quantum number can be represented by 2 values. One is S equal to plus of, another is S equal to minus of. That means plus of means it is the clockwise orientation, it's moving clockwise. We will represent by plus of. And moving anti-clockwise we usually represent by minus of. So only 2 orientations. For electron, that for electron will come 2 orientation. So clockwise orientation we'll call it as plus of. Anti-clockwise orientation we'll call it minus of. That conventionally we can also represent by the symbol that is arrow we can represent. So these 2 values correspond to clockwise and anti-clockwise spins. I have already showed the picture. The clockwise spin is usually represented by an arrow pointing upward. This is the most important. Conventionally, when you are representing atomic structure, we are representing orbital. Suppose this is S orbital, a box, we will write normally like this to represent electron. So electron pointing upward means that is moving clockwise. Electron pointing downward means moving anti-clockwise. This is the convention. So this convention only here. So clockwise spin is usually represented by an arrow pointing upward. The same way, the anti-clockwise spin is usually represented by the arrow pointing downward. So when I am discussing the electronic configuration in the next class, I will explain still in clear way so you can understand very well. So the only remaining part I have to discuss under the atomic structure is I have to discuss electronic configuration. I hope I will discuss in the next class. Thank you.